Example 3.4. Calculate the current I1, the voltages Vx and Vz using mesh analysis. So let's look at the numbers here. So step one. Let's do the numbers. So in this situation, we have to calculate the loop currents. And from these loop currents, we want 3 parameters. I1, we can see right away that this guy is a loop current. So as soon as I get that loop current, that I know what that is. And then I have 2 voltages, Vx and Vz. So when I look at this scenario here, what I'm really saying is that I want solver equations for these guys. So let's go look at the numbers and then see what we have. Paste. So it seems to me that if I call this loop, which is not between two loops, this I1, it's an isolated current. So I'm going to call that current I1. Now, if I look over here, it seems like I'm going to call this 2. And then I'm going to call this guy over here 3. So when I start to look at these things, here's what I see. So I have the number of loops equals 3 minus 1 source, which then gives me 2 loops, 2 loop equations. And the first thing I got to ask here is that what kind of loops are they? So when you look at loop 2, note that there's no current source there. So that's an isolated loop. So that means I have a loop 2. But if you look at this 1 milliamp source, note that that connects loops 1 and 3. So if I look at this guy, this is going to be a super loop between 1 and 3. But every time I have a super loop, I have a super condition, which is between 1 and 3. Now, we have 2 voltages that we got to calculate. We got to calculate Vx and we got to calculate Vz. So it looks like I have 2 solver, 1 for Vx, 1 from Vz. But wait a minute. So I know I have a super loop here. So if I look at this super loop, it goes from here and it goes all the way around and then all the way back. So if I'm looking at my loop current, it's going like this, and then it's coming back onto itself. So the thing I want you to pay attention to is this. Note that the loop does not include this 1 kilo ohm resistor. So, however, I have a 1 milliamp in series with a 1 kilo ohm. So that tells me immediately, let me move down a little bit, that I know what the value of Vz is because that's just the current, right? That's just the 1K times the 1 milliamp. So I immediately know that this has to be 1 volt for Vz. So just by inspection and seeing that these guys are in series, I already know what that voltage is. So as far as solvers are concerned, I don't need VZ. I only need to solve for VX. So now, what do I have? So if you look at this thing, you can see here that this guy is not two solvers, but it's one. So now I have 1, 2, 3, 4. So I have 4 equations, and I have 4 unknowns. And this guy is going to be I1, I2, I3, Vx. So I got a 4x4 matrix. So let's go look at this guy. So I'm going to copy this just so that we don't have to keep going back and forth. So I'm going to copy that, and here I go. So I'm going to put this all the way over here so that I know what I'm looking at. Okay, so here we go. So using that circuit, so now let's look at that. So I have loop 2, and you can see that loop 2 is the green loop, and I have 1, 2, 3 resistors. So then I'm going to have 10 plus 1 plus 1, and then I'm going to have I2. Do I have mutuals? Yes, I have 1 with 1, and I have 1 with 3, and I have 0 sources. Okay, so this is my first equation. Now I have my super loop. Now remember, it does not include the IZ, the VZ resistor. So here I go. I have in loop 1, I only have 1 resistor between 1 and 2. So here I go. So I'm going to go 1 plus 1, and then I'm going to have I1 minus the mutual, which is I2, and then I keep going around. So you could see here is that this guy's telling me what? This is loop 1. Now I'm in loop 3. So if I look at loop 3, note that there are 2 resistors. So then I'm going to get 1 plus 1, I3, and then I have a mutual with I2, so that's got to be I2. And you can see here that this is loop 3. Do I have any sources? So as I go around the loop, look what I get. I get a minus. If I take it to the other side, I end up with a plus 10. This is equation 2. So now I'm going to go to my super condition between 1 and 3. And you can see here is that that super condition, the way it's set up here, is that I look at where that source is at. That source is going down. It's a 1 milliamp. So then I see here is that I have 2 currents. I have a current going down, which is I1. I have a current going up, which is I3. And you can see that the current source is going down. So this tells me here is that this should be I1 minus I3 equals 1. But in matrix form, we don't, oh yeah, and this is in matrix form. So this is 3 here. So once again, let's look at this thing. This guy is with current source. And this guy is against current source. Okay, so now I'm going to look at my solver for Vx. So here we go. I have a solver for Vx. So if I look at my Vx, note that I have a resistor. And this resistor says that this is plus, this is minus, and this is Vx, and this is a 1K. So now let's look at the currents. So this direction is the current of loop 2. This direction is current of I3, and you could see that I3 is in the same direction as the polarity of Vx. So now if I look at this guy, I'm going to say that according to Ohm's law, Vx is then going to be the resistance, which is 1, times the difference between the current, which will be I3 minus I2. And therefore, I get in matrix form, I'm going to write this. I'm going to have I2 minus I3 minus Vx equals 0. And this is my fourth equation. So now let's bring all these equations together here. Right? So let's bring these equations together. So what do I see here? I see that my first equation, now look what I'm going to do. Right away, I'm going to start right here. So here's 1, 1, 1, and that's it. So I'm going to start off here, and I'm going to say this is I1, and this is equation 1. This is equation 2. This is equation 3, and finally equation 4. So I have I1, I2, I3, and then I'm going to call this Bx. And then, of course, I have my constants. So here's the first equation. So the first equation says I got -1. I look at the second equation, you can see I got 1 plus 1. My third equation says that I got 1, and there's no I1 and 2 in equation 4. Now let's go to the green. So if I go to the green, that's I2. So I'm focusing on I2. Okay, there's I2. So the first one, I2, is what? 10 plus 1 plus 1. So I'm going to write 10 plus 1 plus 1. Then I'm going to get, look at that, -1, -1, -2. And when I get to the second equation, there's no I2 here. And then this one is 1. Now let's look for I3. I3 here, there's none. There's 1 in the first one. There's 1 right there. There's 1 right here. And there's 1 right there. So every term has 1. So let's see here. So this is -1. This is going to be 1 plus 1. The second one's going to be -1. And then finally, I get another -1. Vx only occurs in the very last equation. And you could see that Vx here is only occurring right here. So let's write this down. So this is -1, and then everything else is 0. So if I look at my constants are what? 0 and 10. And then I have 1. And then finally, I have 0. So now that I have that, I got it in matrix form. So then I'm not going to go to matrix magic. And then I have I1, which is 4.44 milliamps. I have I2, which is 0.656 milliamps. I have I3 at 3.44 milliamps. And then I have Vx, which is 2.78 volts. So one of them I wanted to calculate was current I1. There it is. And I wanted to calculate Vx. So just to be careful here, what does this mean? So if I redraw the element, it looks like this. So I know that this has a polarity of Vx for the 1K. So if I look at that for the 1K, look at that. I have the current coming in, which is I3. I have the current green going this way, which is I2. So then according to this, Vx should be the resistance of the kiloohm times the current between these two guys here. So if I put them on, that's 1 and then this is milliamps. So then this should be, looking at my numbers, it should be 3.4. Let me move this over a little bit. Should be 3.44 minus 0.656. And if I calculate that, I get 278 volts, which is exactly what we predicted.